This video is section 2 of algebra, first unit. We are finding the slope given 2 points. There are a couple different ways to think about finding the slope. The one that you're probably the most used to is using a formula where you have y2, y with a little 2 underneath, minus y1 all over x with a little 2 minus x1. That's probably the one you are most used to. And often we would say that this is equal to the letter m. M stands for slope. So I'm actually going to write all the way across here that we have m is equal to all of this, which is equal to slope. You might want to write that formula down somewhere on this page so that you can access it later. In the first example here, let's see if we can use that. We need to identify which of these points is which thing. Now when we have a coordinate, it's always going to be x, comma, y. My pen a little smaller here. It's always going to be x, comma, y. And the same thing for this one. It's always going to be an x and a y. But since we have 2 points, we don't want to call both x's the same thing because they would get mixed up. So we're going to call this one x with a little 1, and this one's x with a little 2. And this first y coordinate, since it's paired up with x1, is going to be called y1, and since this y coordinate is paired up with x2, it will be called y2. So now we have a label for each of these. So now we can plug them into our formula for the slope. And if we look below, it says we have y2 minus y1. So that means we're going to start out with 20 minus our y1 of negative 15. So 20 minus negative 15. That is all over x2, which is 16, minus x1, which is 7. Now as we go to clean this up, we see minus a negative. That always means we are adding. So I'll change that to a giant plus sign up there just to reduce any confusion. And 20 plus 15 is going to be 35. So we'll have 35 on top. 16 minus 7 is going to be just under 10. It will be 9. 9. And both numbers are positive, meaning that our slope is going to be positive. Sometimes we have one number that ends up being negative, or both numbers end up being negative, and we need to adjust for that. But this time we have 2 positive numbers, and that fraction, if you were to type it in your calculator, it will not reduce. So 35 over 9 is our final answer for the slope. I'm going to show you a different method over here, one that I prefer, that I find a little bit easier. It's essentially the same thing, but it's a different way of doing it without the formula. Since slope is always the change in the y above the change in the x, I will look at how far apart my y values are. And in this case, my y values are 14 apart, because 14 and 0 are 14 apart. And then I look at my x values, and I see that 20 and 2, if I subtract those, they are 18 apart. And since it's always y over x, my slope is going to be 14 over 18. And then I would need to reduce that by dividing, it looks like they are both even numbers, so I can divide them both by 2. And that would give me 7 over 9. So that is the reduced fraction. The last thing I need to check when I use this method, because it's a little bit sloppy, it doesn't keep track of order that well, I need to check if I have a positive or a negative slope. And so I'm going to draw myself a real quick sketch. And on that sketch, I'm going to see the point 20, 0. And that's going to be out a ways, but not very high up. It is going to be right on that axis. And over here, I see the point 2, 14. So over just a tiny bit and up a lot. And when I connect those, I see that I have a downward sloping line. As I go from left to right, the same direction I would read if I go from left to right, I notice that my line is going down. So when you go to the right, if the line is going down, it is a negative slope, which means I'm going to put a negative sign right there on my fraction for the slope, and that would be my final answer, -7/9. You go to the next part here. We're still in section 2. We're finding slope using a graph now. Since slope is always the change in the y over the change in the x, I can look at a couple points on a graph and say how much did the y change compared to how much did the x change. And in this case, the y changed 1 unit and the x changed 2 units. So the change in y over the change in x is going to be 1/2. The last thing I check when I do this, just like my method in the last one, is whether or not I have a positive or negative slope. And since as I go from left to right, the direction I read, I am going up with the line, I'm going to have a positive slope. So this can stay as a positive number. And since all I need to find is the slope, that is my final answer. Over here on this line, I'm going to look for the change in y, which is going to be 1, compared to the change in x. And that's going to be 1, 2, 3, 4, 5. I count 5 full squares. Make sure you're counting squares, not lines, because there are 5 squares and 6 lines. 5 is the correct distance here. So the change in the x, the run across, is 5, which means my slope is going to be change in y over change in x, so 1/5. Last thing I check is the direction I read from left to right. I appear to be going downhill. And when you're going down in that situation, you have a negative slope. So I'm going to throw in a single negative sign here to indicate that this slope is -1/5, not positive.